Please welcome Hans-Peter Blachowski, Austrian Institute of Technology.
Hello everyone, nice to be here, and I'm very excited to be here and present today a very new application of new sensor technology. The company is called NOSI and is led by Patrik Aspermair, who led a multidisciplinary research team from surface chemistry, polymer chemistry, IoT devices, advanced printing technologies, and a multitude of different AI technologies in that respect. As a result, the team has developed a new IoT-ready sensor which is capable to detect tiny traces of molecules just like our noses are. From the start, the team has really captured the idea to apply it in many different applications. And today it is ready for the market. And I'm very excited, of course, for that. The possibilities of utilizing a digital database of odors is manifold, and we are starting today. And I hope you can share my excitement and see that what they have done is worthwhile going forward in an advanced way. Thank you very much.
Breaking the wall to smelling machines. Patrik Aspermair, NOSI.
Hello everyone. Did you know that only 3 of our sensors have been digitized and commercialized yet? So there's a reason to it, because the vision, audio and tactile sensing are the direct translation of a physical instance to an electrical signal. But smelling and tasting is the translation of chemical signals to an electrical one. So how does the human nose do it? We express proteins in our nose, then we send this with many different proteins in our nose. We have about 300. We send the information to the olfactory bulbs. We learn it, we learn the smell, and with our experience, we memorize the smell, and then we can recognize the smell again. Like a newborn baby cannot know how a banana smells, but after the 100th time of smelling a banana, it knows it's a banana, and after the 1000th time, it could maybe distinguish between a fresh banana and an old banana. So how is NOSI doing it? We have a patented smelling processing technology that is fabricating the sensors in an automated way. We produce the sensor array that is with those polymer sensors on top and makes a smell pattern to it. We amplify it with our circuit, and we have a smell training machine, not a virtual machine, but a real machine that is capable of sniffing to the particular smells and training for the patterns. And therefore, we learn the KI-based or artificial intelligence-based database to recognize the smell again. And we managed to put this technology in our tiny device that consists of a sensor cover, a processor, and a data transmission. And it is so low power that it can be even powered with an indoor solar panel. It's IoT compatible, low energy, a very scalable product, and low cost. And the best is it's versatile and can be adapted to different use cases only with software adaptations. We have a patented printing process, a patented training machine, and our secret polymers that are on top of the sensors. It's like the Coca-Cola recipe, but not one time, but many times. So I'm not sure if you're aware of fire in warehouses, but fire is really a big issue in warehouses, and about 30% of those fires in huge warehouses are caused by electrical fires. And it costs them about 300 billion euros alone in the US. And one fire incident is about 150,000 euro of loss, not even talking about the aftermath. And the number of warehouses is increasing, and you maybe read the headlines of warehouses being down for several months just because of one incident. What is the solution of NOSI? We provide an early smell detection even before the fire starts. So we recognize the smell like some electronic devices that start to smell before they even ignite. And we send in a dashboard then the information that you should maybe check shelf 305 because it's on fire. It starts to maybe be on fire soon. And with this, we can be even faster than classical fire detectors by about minutes and maybe even 1 hour. The market is not only warehouses, it's also in smart buildings, but also factories. And now you think, but why warehouses? Why smell sensing in warehouses? Well, this is just one thought that we have, and it's the reason is because it's a market that is accessible and also a rather rapidly growing market. But you are right, there are other markets like smart building, smart care, smart building for air quality, measuring, also turning on and turning off the ventilation upon need, but also elderly care and taking the crop farming into another dimension. And the best is it's not 4 different sensors, it's the same sensor, and it can be trained only with smell sensing, and we transfer the smell know-how to each of the sensors. And it's also idle for odor monitoring for privacy-sensitive use cases, because you do not want to have a camera installed beside your bed. How do we address our market, our partners? So we actually go through a process with our development kit. We go through proto customers or directly with the system integrators. And then once the setting is done and we know the smell that is necessary at our customer, we can give them our sensor and our knowledge of the database and integrate this in the environment they're using it. So we can identify complex smell bouquets. And we have now a few smell sensors on it, so-called oxels. And we can actually maximize it to maybe 1 mega oxel in the future. The business model is hardware, but especially software. So we want to sell the software as a service, and we can already sell the development kit. We started in 2017 with the technology, and are proud that we could take the IP with us. And maybe I should emphasize that we just founded the company in 2024. So we're not even 1 year old, and we are already able to sell the first products to some customers. And we won a few prizes already. And with a team of engineers, technology-driven chemists, we are running NOSI.
Okay. Great. So that's a digital nose, right?
Yeah.
This is nice name, NOSI. It's really funny. Okay. So, whoa, okay, in a row, so 1, 2, okay, 1, 2, 3, 4, 5 from the jury, 6 from the jury, okay. So let's make it really fast. Ladies first, come on, Iris, let's go.
Thanks for the pitch, super interesting. You mentioned different polymer membranes or layers. I was wondering how many different ones you tested and if every specific one can only do 1 molecule or multiple molecules.
Very good question. So it's all about the pattern. It's not just one polymer for one smell. It's like each of our polymers react slightly different to different volatile organics. And with this, we tried to have it as broad as possible so that one polymer is reacting more, that the other one is less, and to be very complementary with all the polymers. So we have now about 20 polymers that we really established as a formulation that we can apply on the surface, and we use them as our formulations and recipes.
Okay, great. Next question, Luca.
Thank you so much. So you talked a little bit about different use cases for the product. How are you going to make sure, I mean, you wanted to start with warehouses. How are you going to sort of enter the market, reach customers, acquire customers? And it's very different to healthcare, for example. How are you going to address that?
That's a very good question. And actually, all the use cases you saw there were not use cases that we came up with, but the customers approached us with their ideas. And I think that that's the most feasible way, because then they really tell us right away their needs, their problems, and we give them right away solutions to it. Because we also have a training robot that we can actually give them and let them train upon their problem in their environment. So we do not train in our facility and say it works, and then it's at the customer site and they say, well, it doesn't work. So we give it directly to the customer, and we actually help every customer to train upon the smell, because it's way more difficult than facial recognition or fingerprint recognition. You really need to help every customer in an initial phase to learn their smell problem.
Okay, next question. Rasmus, please.
I mean, super exciting sensor. Are there any more complex use cases? Because I feel like also for like the warehouse and so, there might be substitute products that might be much simpler actually solving the same problem, whereas the sensor could probably do much more. So how do you think about competition as well as more use cases?
Mm-hmm. Well, maybe with simpler and cheaper, I do not fully agree. I think we are really cheap with printer technology, but more complex is like, I don't know, explosives and healthcare, but this is for me the Champions League, and it takes like a long run time to actually tackle those markets where we are probably not here anymore until we can reach those markets with all the certifications.
Okay, I try two questions in 1 minute. Please, short question, short answer for both of you.
So
please.
What is your edge compared to competition using still digital smell, for instance, using carbon nanotubes?
Yeah, it's a very good question, to be honest. My PhD thesis was about those carbon-based materials, and I do not trust them so much anymore. Still, they have a very good range in measuring, but the fabrication is way more difficult than ours. To actually select the nanotubes is really a tedious project, and this is not such a scalable process as we have.
Okay, next and last question. 43 seconds. Nobody? No, I'm disappointed. It's the smelling machine I was talking about. Yes, please.
I'll come in because I
Yes.
think it's already been covered, but very briefly, I'm not convinced by your use cases at all. And I think the idea is great, but I think you've got to work a lot harder, and maybe that's not a question but a statement on where you're pitching first of all, because you've got a generic here. Could be a lot of different markets. You can only develop one or two of them.
15 seconds to solve the problem.
Thank you very much. I think it's very well stated by our customers that they have a problem there and they have a need there and they are willing to pay for it. So yes, there is way more, and we are still looking for the killer application where we can really scale to the billions. But those use cases help us now to actually ramp up the entire process.
Okay, good. Thank you very much. Good luck for NOSI.